You guys are here. So in the last class, basically we looked at say as the architecture of an LLM, right? We looked at like how do LLMs process text, how do they understand the human language, and then how do they actually generate the answers. So the attention mechanism, the feed forward neural network, and the last logits layer where it does the prediction and all. So that was all the architecture that belongs to the architecture of an LLM, right? So today the agenda is we'll be covering the end-to-end life cycle of an LLM, what is pre-training and what is post-training. Like in our normal software development, we have a software development life cycle, right? So when these big companies, when they make the model, right, they also follow a life cycle. Okay, that is called the LLM life cycle, and we'll look at end to end, like what does the training phase look like, what happens in the training phase and all, from a life cycle perspective, not from an architectural perspective. Last class we already looked at the architecture of the large language models. Okay. So basically, so how do we train the large language models? So we know that already that a typical LLM training cycle takes months of training time, right? It's not 1 day or 2 day training. Generally, when OpenAI or Meta, they are training the model, it would take months for them to train the model. Okay, and it's a multi-million-dollar GPU investment. Like I had covered in the hardware section of the models, right? Like we cannot run the models or train the models in a simple CPU-based system. They need GPUs because they are so large, right? They have so many parameters and all. So the overall investment these companies make is a multi-million-dollar investment, and it requires huge compute resources like GPUs and all, right? And obviously, it requires a team of researchers and AI engineers, right? So now, this is the overall training life cycle, the diagram. Keep this in mind, and we'll talk through the different phases today, right? So basically, to start the training of a large language model, first and foremost, what do we need? We need the data sets, right? Uh, what do you mean by data sets? The data on the internet. That is what the model learns on, so that it can know everything about the world and then predict answers based on your questions, right? So these data sets are taken, they are like trained on GPU clusters, and then after the initial training, you get a base model. Okay. Once the base model is ready, right? What does the base model can do? Base model can only, like, let's say if you give it a question, right? It can just predict the next word in the sentence, right? That is what a base model does. And a base model does not know that it should not give, harmful instructions to the user, right? Let's say you tell today, if you go in and tell any of the LLMs, right, that help, I want to create a bomb, for example, right? So it will not give you the instructions and all because it is considered as harmful, right? So but the base model does not know that already, right? So it does not know, it just knows how to generate the answer or the next word. It does not know that how should it not give harmful toxic answers and all. So that is what we'll do after a base model is trained, right? What we will do is we'll teach it how to answer first in the form of a Q&A set, which is like today, if you go in and type in you basically interact with any LLM in the form of a Q&A, right? You give it a question, and it gives you answer back, right? So the base model does not have that capability. It can just fill in the blanks or predict the next word or give very raw answers. You have to basically take the base model, and then train it on answering in the format of a Q&A form, right? So Q&A data sets are provided to the base model. Then it learns how to give fine-tuned answers in the form of a Q&A, right? Now, once it answers in the form, now it has learned the capability of answering in the form of Q&A, right? So now, but a question can have multiple correct answers, right? Like option A and option B, right? So we also want to do one more thing is like we want to teach the model that what is the answer the humans can prefer, right? If it's an open-ended question, there are four sets of answers. What answer is more accurate or more relevant, or what is more human preferable, right? So that training also we give to the fine-tuned model. That training is called reinforcement learning with human feedback. Okay, so that training is given to the model as well. Then the final result is a trained model. Now this trained model can be used by any of the users like us, right? Then we query the model and the model will respond back with answers, which is called inference, right? So we will look into each of the phases, like like how is the data preparation done, right? Then what is pre-training, what is post-training, and then how do we get the whole model, right? So on an high level, from data sets, from taking the data sets to coming up with the base model is called pre-training. Okay. And once you have the base model, till the trained model, whatever training you give, right, this whole part over here is called post training. Okay. So we will look into each of the phases today. Okay. So let's start. Okay. First, how LLM labs actually train out the models, right? So I said pre-training, which is coming with the base model, right? So what happens during the base model? Phase where the model reads trillions of tokens of text and learns the language, facts, and reasoning. This we already know that what it will have is it will have a data set, will pass all the data set, and here the language will learn how to reason about what is the language and all those things, right? This whole process is very expensive and irreversible, right? You want to train a model and give it out on the internet. Like I said, right, it takes millions of dollars of investment and high compute time, so it's very expensive, and the process is irreversible. You are taking months of time to train the model, right? So you have to come up with the right strategy to train the model. Otherwise, like once you start the training and at the end you find that, okay, I didn't train the model correctly, this can be very expensive and it cannot be changed later. So that is why it's expensive and irreversible. Okay. So
So
like,
during this training, Ankit, will can we give a URL like take all the knowledge from Wikipedia and load it into the model, something like that?
yeah, yeah. So what generally happens is we will convert. So I didn't. I have a section coming up next wherein I will cover like what are the actual data sets passed to the model. Like big companies like Google and all, what they do is like they scrape the whole of internet and create a data set like all the Wikipedia articles and stuff, and then they feed the model, and then that is how the model learns. Okay, but not
Okay.
everybody, Google will not give its data to everybody, right? So how do other
Mhm.
companies do? We'll cover that in the data set part. Okay,
Okay.
just after this section. Yeah. So choosing the right architecture, the learning rate, and the architecture is very important. Okay. What is the right tokenizer? We should see whatever we saw in the architecture section, right? The neural network depth, the tokenizers, the like how do we come up with the vectorizations, all that steps must be confirmed before like going into the actual training phase, right? Because that is important. So how do we do all this? There is something called as ablations. Okay, don't go about the word, like it simply means is like we do some small and fast experiments to test the ideas before going full scale, right? So now let's say what I mean by this is like during the pre-training phase, right, what people do is let's say you want to test an idea, right? So you will not go in and test that idea with a 400 billion model for 3 months. You will give the data and see whether the output is correct or not, right? You will take a small part of the model and then just train it for 2 days and try to see the output, right? Whether it's coming correctly or not. Similar to programming or any other thing, right? If you want to use a library or if you want to test a small code, what do you actually do? You actually write a separate file, right? Wherein like you will use the library in a small, like in a very basic way, test whether I am getting the right set of output for the input, and then use it in your company's code base, right? Like let's say to avoid the build process and then giving the output, it will take a lot time, right? So you create a small script and then test out whether the concept is correct or not, and then you include it in your code, right? So similarly, like since we are talking about the SDLC of a LLM model, so if they have to take some architectural decisions or something, what they do is they do this ablations, which is like to test concepts. Hey, I should use this, not this, right? I need to prove this theory, right? So what they do is they take small models, test that concept on that, and then apply the same concept on the bigger models, right? What it happens is, like, let's say if you want to, for example, right? So you want to see that I want to train the model more on code, more on books, or more on like some multilingual data based on like what do you want to what is the core capability of the model, right? We saw that there are different family of models. Some are good at reasoning, some at video generation, some at audio generation, general purpose models, right? So if you're creating one of those models, you first try to experiment. If my purpose is to generate a model that can give me good coding answers, I need to try data in different formats, right? So what I'm trying to say is you try to experiment with the smaller model and see whether it's giving uh, correct results, rather than going into like passing on all the things to the bigger model and then waiting for 30 days for it to evaluate whether it's giving right or not. Similarly, if you have to do some architectural tweaks, right? Last time I said that there are 96 layers used in neural network part, right, for the LLMs. So how did they come up with that this 96 layers will work, right? So did some experiments, right? That this amount, if I use this amount of layer, I get correct answers. So the whole point being is like ablations help you. They are small experiments that you do based on like some choices that you want to take, that helps you to, and then pass on the same experiment based on whether it was successful or not successful into the bigger model, right? So what basically it will help you is in preventing backtracking. If you just give it to the bigger model, after 3 months of time you have wasted millions of data. Now you will come back and see, hey, model was not behaving correctly, we have to correct this, right? That should not happen. Just I took an example for that. You are 6 weeks into a 12-week training, right? Model suddenly gets worse at coding, right? You obviously, the team will get into panic and revert the changes in the data set and all, right? So, but if you have done ablations or experimentation further, right, you can confidently say that, hey, this is a temporary dip, right? I know it is for a small amount of time, but the model will predict correctly after 12 weeks of training. So it gives you that confidence. So ablations are nothing but like decision journal for training. Okay. So here, what I'm trying to say is today, like I said, right, we'll cover how the model is trained. So we'll look into all the aspects. Like think of it like you are in a team where you have to train the model, right? So how will you handle scenarios, right? So first one was ablations, which is like doing small experiments on smaller models so that you can come to certain conclusions and then use it in your like production data. Think of it as like dev and prod. Also, you can think of it like that, right? Now we also do the second part is, first part is this ablation, second part is eval-driven development, right? So in the normal software development lifecycle, what do we use? Some companies use test-driven development, where what do we do is like we define the test, we write the code, and then we write the code until the test passes. We have to modify the code, right? Because we want the test to pass, right? So now think, now I'll give you 1 minute just to imagine that. Think how people would have tested like GPTs or like these LLMs, right? How will you even test it, right? Think about it. I don't want you to give me an answer, but just think about it. That you are from the QA team or you are from the development team, and now you got the model. How do you actually measure the performance of the model? Because the constraints over here is the model can answer any, I mean, it can give you answers based on anything, right? You ask it a coding question, it can answer. You ask it a life science question, it can answer. You ask it a law based question, it can answer, right? So how do you actually measure, right, that whether it's giving the right answer or the wrong answers, right? It's very difficult because in normal development, you know that, hey, this code should predict this, this is the input, this is the output, right? It should be able to predict that, right? That's easy. But how in these cases will we actually evaluate whether the model is working or not, right? So what we do in case of LLMs is we use something called as evals. Okay, they are called evaluations, and they are like different, like same to our test driven development, but they are basically called benchmarks. Okay, what is the benchmark? So what do we do in how do we create evals? Is like we create basically data sets. Okay, and then we measure how is the model performing in this particular data set, right? For example, like let's say if I have built a model, right? So how will I evaluate it, right? How generally these chat GPT and these LLMs are evaluated is there are evals benchmarks, right? So let's take an example. What are the different kinds of evals present? Like let's say knowledge evals are there, right? It is called MMLU. I'll show you an example. They are basically data sets. Okay, what does this data set contain? Uh, it has questions related to 57 subjects, right? Physics, history, law, medicine, all of this. Once the model is like going through the training phase, right? So after specific points of time, I will test on this particular data set. What is the response of the model, right? How good is the response of the model? Let's say I want to see how is the model performing on maths reasoning part, right? So for that, there is a separate data set called AIME, right? So what does it contain? Competitive level math problems, right? So I pass all these questions to the model and see how does it answers, right? If I have to evaluate how the model is behaving to answer code related questions, I have this particular data set, which is called SWE-Bench, which what it has is like different code bases and different issues in them, like different GitHub repos or something, and all the issues in it. And then it's passed to the model, and model is asked to answer those questions. And then we evaluate how does it answers to those questions, right? So I'll show you one particular database so that it gives you an understanding of how actually it looks like. So see, this is one data set MMLU, like I said, right? So see how is it? There are questions like find the degree for the given field extension, like some sort of math questions. And subject is given. What is the subject? Then what are the different choices? And what is the answer? Now this will be given to the model and ask the model to predict the answer, right? The answer will be masked, and then the model will be asked to like predict the answer, and it will see whether the model can come up with the right answer or not. If it matches this B which is given over here, then the model is doing good. If it's not if it does not matches B, model predicted A, then it's doing bad, right? So it will evaluate like what is the output of the model. I know the answer already, so we will know how the model is performing, right? So this is how data sets in general look. You don't have to go in like for your specific use cases, company use cases, you might need to create data sets like this, right? But the models, the LLM models which are present on the internet, right? They are trained on these data sets, like data sets like this. Okay. Okay. Now let me come back and show. Yeah. Move to the next part. This is how a data set looked like, right? So now for, like I said, right, when you are designing a data set for eval, or when you are designing a eval, you have to keep a good eval has two properties, right? First thing is like it should scale, right? What it means is like it should have a mix of difficulty levels. As we Because let's say the it should have a mix of difficulty levels. I'll come to this point, like why is this point important. As we train more, the answers will improve. It will, if all questions are at the same level, you might not know, right? Now let's say so what the point is, it should be able to scale. It means is like the data set that you are creating should have different difficulty levels questions. Because think of like this, like you're training the data, training the model, which is an iterative process, right? During the initial phases, or like in the first loop or the second loop, right, we are training the model at different levels, or multiple epochs are taken, right? Like I had explained the epochs during the neural network, different cycles or loops, you can think of it like while the model is training. So after the first or the second loop, the model can only answer basic questions. After the fifth or the sixth loop or the 100th loop, the model becomes more trained. Because it trained on more data, it can answer and it can give you better answers, right? But you need an eval which can see whether the model is making progress or not, right? So if you give all the hard answer questions only in your evaluation, right, during the initial phases of the training, what will happen is model will give zero answers because it's not trained on the whole data. But we want to see whether the model is making progress or not, right? So that is why we'll give a mix of questions, so that I can see if I've given 100 questions, when I've trained the model 10%, it can give me 10% answers, right? If when I train the model 20%, then I see that okay, it can now give like 20% answers, so on and so forth.
Same question can be asked in different ways, right? So how is that being trained?
Yeah, I'll come to that part. I mean, just below the slides, I have that answer. Okay.
Okay,
So
okay.
so I'll give an example, like what is bad eval, what is a good eval. Okay, just this example will make your question clear, Swati. Okay. So let's say if you are creating a data set, right? In the data set, what questions did you give? Like, let's say if you are creating a math-based model, you give questions like this. What is the derivative of x cube? What is the derivative of x square plus 3x, right? You give 100 questions like this. Small models, which are like right now they are less trained, it will just give you 0% of the answers, right? Because they have just now learned what plus minus, or like just a concept like this, they have just learned basic terms right now, right? And big models which are already trained, they will give you 100% right the answer, right? So this is not a good eval. Why? Because I have only given hard questions, and only when the model will be completely trained, it can answer these questions. So what will I do during the training phase? How will I measure whether the model is learning correctly or not, right? So what a good eval instead of this would have been, I would have given what is 7 into 8. The next question would, this would be the first question. The next question would be solve for x, 2x plus 8 is equal to 13. Well, like find what is x. The third question would have been what is the derivative of x cube. So see over here how the eval is designed over here, right? You have different difficulty levels of the question. So during the training phase, you can so after the first few training cycles, it can answer this question. So okay, I trained it this much, it can at least answer this. After some more cycles of training, it will be able to answer both of this, right? So the accuracy of the model will increase by 30%. After a few more cycles of training, it can answer this also. So you'll know, okay, how the model is progressing. Does this answer your question, Swati?
Yeah.
Okay, cool. So this is what the property of a good eval will be. Like we'll get into like more details of like what eval should look like. But on an high level, eval should be designed in a such a way that it scales, right? You understand what is like scaling, easy to hard part, right? Now, the second property that it should have is it should have stability, right? What does stability mean, right? If you run the same model on the same eval twice, you should roughly get the same score, right? So your questions in your data set should be in such a way that if you run the eval, like or you pass the data set to the model twice, right, without training it, like you have trained the model like for a few cycles. Now you take the data set and give it twice, right? So the data set should be in such a way that it should always give like the model's accuracy is right now 30%, and when you give it the second time, it should be 31%, not 30% and 60%, right? If the data set is designed in such a way that it is the variance is so much, that means your eval is not good. How? Because let's take an example to understand this, right? We know that LLMs are non-deterministic in nature, right? They are probability based, right? It's not that if I give in the same question, it will use the same words to answer it, right? It might use different words and all to give you the answer, right? So now let's say if your eval has 20 questions, right? And if you choose your questions in such a way that they are all open ended, right? So what will happen is after a certain training phase, if for run 1 for the eval model scores 70%, run 2, because they are open ended questions, there can be different variations of the answers, the model will give a score 58%. Run 3, the model will score 75%, right? You see, this is like kind of useless because you cannot actually predict whether the model is learned or not, right? How will you predict based on this data whether the model is ready for production or not, right? Because you had in your eval, you had kept open-ended questions which could have multiple answers. Rather, a stable eval would have been, I gave 20 questions, but let's say multiple choice questions, which we saw in our previous data set, right? It was multiple choice questions, right? Which have exact answers, right? That the answer for question 1 should be this only. For answer of question 2 should be exactly this, not an open-ended or a theoretical question, right? Then you can evaluate whether the model is making progress or not, right? So 2 points for evals. It should scale. It should not be noisy, right? It should be very stable. And what does stable or noisy mean? The question should not be open ended, it should have like clear cut answers. So this is how, like when we are developing a model, this is how we will, this also the evals also we have to design, right? Tomorrow you will go in your company and train the model in your company's data, right? So you have to come up with a testing framework or an evaluation that how is the model behaving, or how, what is the model correct or not. So evals are for doing that, and this is how, these are two properties on based on like how eval should be created. Okay, so still, so don't think now from a company perspective, but right now what is happening is I'm telling you like what OpenAI or what Anthropic does, right? They also have their evals in place. Like while they are creating the models, they keep on checking from time to time based on the evals, like what is the accuracy of the model, right? Now let's come to the next part, which should have actually been first, but I mean somehow I created the slides in a different way, so it got messed up. So now the next part is we saw pre-training. Okay, after that the base model comes, but where does this data come from? Okay, we had this question also. So let's look into a little bit into like where does this particularly data come from, right? Like I said, large companies like OpenAI, Google, and Meta, they have their private data sets. Okay, they have scraped the internet and created their private data sets So you can think of it like why closed source models are better than open source models, right? These closed source models are they belong to these big companies like OpenAI, Google, and Meta, right? So they have their own data sets, right? So which is like on all of the internet, right? So obviously when you train the model on that kind of data, the prediction or the output of the model will be better, right? So that is why the models from these companies are better, right? Because their data sets are better. For open source models, these companies don't provide their data set, right? They will not even like disclose it or give it that this is the data set on which the model was trained, right? So that is why open source models are trained on some lower kind of data sets. So that is why their performance is not that better, right? Scrape like open source models, right? They cannot go in and scrape the internet. Only Google can scrape the internet and get all the articles from the internet. It's not possible for all the companies, right? So that is what the point is. Like why closed source models are better than open source models, right? But what do these open source, what is the data that these open source models are created on? Like there are some publicly available data sets, okay? What people have done is like if you are creating a model for your company or something, they have created some publicly available data sets also. uh, like they are called fine web 2, right? If you go in and search, you will get this data set. Data sets are nothing which I showed in the previous thing, right? You will get a articles, all of them clubbed together, where they have removed like stop words, duplicates, and all of them, and they have created a data set. So fine web 2 is a data set. The pile is a data set. DCLM is a data set. You can go in and search about these data sets. They are available on the internet. And if you are creating, let's say, your own model, you can train your model in these data sets. Okay. Now, let's say you are creating a coding specific model, right? Like Cursor or GitHub Copilot or anything. Then and you want to train the model, right? So these data sets are available. The Stack V2 star coder data. Okay. And what does the data processing pipeline looks like? Is like you have web pages on the internet. Okay. So how these data sets are created, I'm talking about that part. Okay. So you have web pages, basically you have crawlers running in, then you have extractors which go in through all these web pages, extract the content of the main web page. You get the data, the metadata, and then you do some deduplication on the data. Okay. That duplicate data should not come in. You anonymize or remove the PII information, that if because it's the data on the internet, right? We should not give it can have personal information of people, right? So we need to anonymize the PII information. They are done that. If the data has like toxic or harmful information, we remove that, right? Like I took an example, the article can have a content related to creating bomb, so we need to remove those articles, right? And then the final data set is created, right? The final data set looks like this, something like this, the ones that I mentioned like over here, right? So so to create all these pipelines and stuff, right? Apache Spark is oftenly used for this data pre-processing. So, like I said, after you get the data, we have to remove the duplicates, we have to remove toxic or harmful content, and we have to remove the PII info, right? So till this point, it is clear, right? Now after you have got the data, and this is the process of creating the data, now you want to feed this data to the model, right? So there are a few optimizations also that are done during that particular process. There are specifically two specific optimizations. One is called sequence packing, and the other one is called document masking, right? Model processes the data in a fixed size called chunks, right? So the model will take the input data in a fixed size called chunks, right? They are called sequences. Like it can take the data in 2048 size, 4096 8192. It's not like you can give any amount of data. It only takes the data in certain chunks, right? So now the docs can come in like this, right? Doc 1 can have only 50 tokens, or 50 should be its size. Doc 2 can have only 50,000 tokens. So now if you have to feed in doc 1 or doc 2 to the model, you see there will be some problem, because if you just feed doc1, right, you cannot, because some space will be wasted. The model can take in that these many bytes of data, for example, or these many tokens of data. You have just 50 tokens. So what you will do is you will take the 50 tokens, let's suppose it is a tweet, and then you will pad the information for like the remaining 4046 tokens, right? Similarly, if doc2 is there, you will split the document and then put it, and some space might be left over there as well. So to handle this part, what we do is sequence packing. Okay, what does sequence packing mean is, like if we have different kinds of data, right? We try to club them together, like a tweet of 50 tokens, a blog of 800 tokens, article of these many 2200 tokens, and forum post of 104. I club them all together so that the full capacity is utilized, 409 tokens used, right? Similar documents are packed together, right? Why are we getting into, like, why do models get into doing all these? Why I'm telling you this is, like I said, my first point, right? Training the model is a multi-million dollar thing, right? So we should do as many optimizations as possible. On a low level, you might think of like doc one is 50 tokens and doc two is this many tokens, smaller docs are there. What is the, I mean, it's okay, right? But think about like when you are training on a very large scale, right? Losing like 400 tokens or 4000 tokens, and if you're just sending 50 tokens while the model has capability to process like 409 tokens at once, you are losing a lot, right? So that is why you do all these things, like sequence packing, wherein you club all the documents together, right? Sequence packing was one thing that you do during the pre-training phase itself, right? When you're feeding the documents to the model. Now there is a problem with sequence packing, right? We learn during the attention phases, like when a model has to understand the meaning of a particular word, right? It looks around all the content around it, correct? We looked at this part. Now the problem is, if you have clubbed together all these documents together, if the if the if the model is now trying to understand the meaning, so that it can come to a context like what's going on, it will look into all of this, right? So which can become unrelated. My tweet was unrelated, my blog was unrelated, my article was unrelated, right? So it should not look around this to understand the meaning of the sentence, right? So that is where like document masking comes in. What I do is I'm packing all these four documents together, but I will mask the document, the tweet, for example. I will mask it in such a way that doc1 can only see doc1 tokens. Doc2 can only see doc2 tokens. Doc3 can only see doc3 tokens. Multiple, but the advantage we are getting with sequencing is we are processing multiple documents at once, and also not mixing them up, so that the understanding of the model is still intact. Okay. This also happens during the data processing phase of the model, right? Now, the third optimization that happens is we do batch training. Okay. What is batch training? Till now, we have seen we have the data, we cleanse the data, we pack the data, and we mask the data. We are clear why did we do the cleaning? Why did we do the packing? Why did we do the masking, right? Now it needs to be passed to the model. So you don't feed the training samples one by one, you do it in batches, right? A batch is a group of training samples that get processed together, right? Now, let's say if you have like this, right? Uh, some sequences, like I told over here, right? We pass the data to the model in sequences like this. Now, what I'm trying to say is, instead of passing one sequence, then second sequence, and then third sequence, it's better to batch these sequences all together, right? Because what happens if you don't do the batching is, like, you pass in the sequence one, then it goes to the model sees whether the answer is right or not, computes the loss, and then updates the weight, right? Then it will do for sequence 2, update, find the loss, update the weights. Then sequence 3, find the loss, update the weights, right? So it's a very slow process. Instead of doing this, what we can do is we can batch them all together, send it to the model. Now what will happen is like sequence 1 to 64, everything is sent with a batch size 64. It will compute the overall loss between these sequences and update the model weights. Similarly, I'll send the whole batch together and update the weights. Try to recall this part wherein like during the neural network pass or during our LLM architecture phase, what did we learn? That we pass the input sentence to the model during the training phase. I'm not talking about inference. This is totally the training phase of the model. Okay. So during the training phase, what did we learn? We pass some input to the model. We tell it, hey, predict the answer. What's coming next? Okay. Or give me the answer to this question. The model takes a guess. Okay, the model takes a guess, then we see that we already knew the answer from our training data that this should be the answer, right? But the model, let's say, predicted something else for the first pass, right? When it's not trained, then what do we do? What do we do? What do we go back and do? We update the weights of the model. That is called training, right? That is how the model learns, right? So what we update the weights of the model. So what we are telling over here in batch training is, instead of doing that in like smaller sequences, let's send the data in batches, so that let's say for like 50 articles, I send it all together, the model will give me some right or wrong answers. Based on that, we will automatically update the weights in one shot. I don't have to do it sequentially because it might become slow, right? Here, if you connect the dots also, right, we said that we are using GPUs, right? So we have to fully utilize the capacity of the GPU because it has multiple cores. So that is why we should send in batches, right? So this is batch sizing. So when we hear about like a model has certain parameters, right? When you create a model or when you look into any machine learning thing, right? They will say that there are some hyper parameters. So what are those hyper parameters? Things like this only, like what is the batch size which I should send to the model, and all these things. They are only the parameters of the model which can be tuned by us. Okay, these are also I mean, you should be able to appreciate these factors. Like these are also important parameters, as in the sense like your output of the model or how do the model behaves also depends on this, right? You have to take a fine balance between this, right? Like let's say it should not be too small, it should not be too large. So during the training phase, you identify all these things, right? That what is the batch size we should give and all those things. Now, this was all that we do during the pre-training phase. What did we learn? First, the batch training. Then we saw sequence packing and document masking. We looked into like what is the data processing pipeline, and then evals. Okay, so all these things we have to design, and these are a part of the pre-training phase of the model, right? After the pre-training phase, what happens is the model can still just construct basic sentences. It still does not know. It's an assistant. It has to answer in the form of Q&A format. It cannot follow instructions, can generate toxic or harmful content, like I said, right after pre-training. So coming back to my initial diagram, like I said, this is the pre-training part. Till now we have covered this pre-training part. What happens between, like before this phase, before you get a base model, what all things you have to do in the SDLC lifecycle of a model, right? Okay, I'll take a pause. Any questions till this point? Is it making sense? Is it clear? Okay, sure. I hope it's making sense, guys. You can respond with a yes, no.
Yeah, they're following up.
Yeah, sure. And I think, Manoj, this will specifically be useful for you, the evals part and all, which I spoke about, right?
Yes.
Sure. Anjali, what about you? Yeah. Is it making sense? Sure. Okay. Okay. So now the pre-training of the model is done. We got the base model. Now what happens in the post-training? Like I said, right, pre-training just trains the model to give fill in the blanks, for example, right? It can just give you a fill in the blank, right? It will fill the blank for you, but it does not know how to give the answer in the form of a Q&A format, right? So that will be taken care in the post-training phase. The goal of the post-training phase is to improve the reasoning capability of the model, uh, teach it how to use tools, okay? Format its tone, like keep your tone like with like it responds in a very warm way, right? The model that, hey, I am your assistant, or it gives you a very, I mean, it gives you very happy responses or tries to be very helpful, right? So this tone is also taught to the model, right? And it is taught that how you need to be safe, right? How you should not generate toxic content or harmful content, right? So this is a part of the post training phase. By the end of the post training, model can now answer queries in the production style, right? Whatever we used after post training, it's given in the hand of the users. Now users can use it. So what did we say? We know till the pre training, after the pre training phase, we have the base model. Now we'll take the base model, do supervised fine tuning in it. We'll get a fine tuned model, and then we will also do reinforcement learning. I'll come to this, but two major parts is like supervised fine tuning and reinforcement learning. These two are done on the model, and then the final model is ready to be used by the customers, right? So what exactly is supervised fine tuning? Very easy. You train the model to respond in Q&A format, right? How? Again, for that, we create certain data sets which are in Q&A format. Example, the data sets will be in this particular format where you will give the instruction, you will give the input, and you will give the output. So let's take an example, like I said, right? Different kind of data sets can be created. So one example for SFT training, the data set which is there is called Stanford Alpaca. Stanford created this data set, and it's available over here. You can go in and check, right? What does this data set look like? Again, this is to help the model respond in the form of a Q&A. Okay, so how will it look like is it will have an instruction. Rank the following cities according to their population sizes. It will have, so how does a sample doc in that data set looks like? I am explaining over here, right? Like I said above, it will have an instruction, input and output. So it will have an instruction, rank the following cities according to their population sizes. It will have an input. This is my input, and it will have an output also, that Tokyo, with an estimated population of this, is the most popular city, right? Shanghai next, and then Dhaka, right? So now what we will do is we will pass this data set to the model. First, we will take the query, right? What is the query? Which is just the instruction plus input. It goes into the model, right? Model produces the output tokens, its prediction, right? Now we compare the prediction to the ground truth. What is the ground truth? This is the output, which we already have with ours, but we will not give this part to the model. We will just give instruction and input and tell that give your answer. Okay, it will give the answer. Now I will compare this output with this output which I already have with the output that the model gave. Right? It can be right, it can be wrong. I will compare that. I will compute what is the loss. There are some parameters in the model which can help it answer in the form of a Q&A. If the answer is not correct, I will calculate the loss and go and update the parameters of the model in the similar fashion. Like we looked at the neural network one, right? We looked at back propagation, right? Same thing will happen over here. Back propagation will happen and it will update. So in the data set, there can be multiple docs like this. All the data will be fed in the model will respond. If it's right, all well and good. If it's not right, we will update the parameters of the model that, hey, you have to adjust your weights in such a way that you can give the right answer next time. Okay. So this is how SFT training will happen, which is called supervised fine tuning, right? Now, let's say this is supervised fine tuning on generic models like closed source models. Similar thing will happen if you want to train a model based on your like company data. What you need to do is you need to convert your company's data into, like, first you need to train the model on your company's data. Then what will you do is you will create certain data set which will have instructions input output format, and then you will train the model to answer in your company style. Okay, so this can be done. I just wanted to take an analogy, like what does supervised fine tuning means in terms of a company specific data. And tomorrow we will take one model, I will take one specific example, and I will train the model on that particular data, and then we'll see whether the model can answer based on that or not. Okay, we'll take a specific example, but first we need to understand, okay, from theoretically what is the model doing. Okay, so the first phase of the training was supervised fine tuning, which means that the model has to answer in the form of a Q&A. How did we do that? We created data sets. The data sets has had docs in it in the format of instruction input and output. We removed the output part. We told the model predict the output. The model predicted something. It could be right or wrong. If the output was wrong, we went in and updated the parameters of the model, right? So this is what is happening during the training phase of the model. Now during the post training phase, the second thing which I told is the model will teach also the model tool use, right? So if you go today into so what does tool use means, right? So after SFT, supervised fine tuning, the model can follow instructions and answer questions, right? But it still has a fundamental limitation, which is it can't look up things, it cannot do calculations, it cannot run code or interact with the outside world, right? So the problem is, like, if you go after you have done supervised fine tuning, right? You go in and ask the model this question, what is time? So what response it will give? I am sorry, but as a large language model, I do not have capability to access current time or date information. Okay, it will say that I don't have access to this because what is the current time? I mean, no, we are training the model on text data, right? So how can it say what is the current time now, right? It cannot say, right? How can it say? But today, if you go to GPT, it can answer, it can tell you what is the time what is the time, right? So how does this happen is we teach them how to use tools. Okay, so the model after supervised fine tuning still can't answer questions like this, which needs some tool call. Like if you ask it to what is the time, or do some math 2 into 2, or you ask it to run a code, it will not be able to do it, because they are to answer those questions which are like live or involve some calculations. A model has to learn tool calling. Okay, so what is tool calling? The model knows it can't tell time, but what if we but what if we taught it to use tools, right? So after tool use training, what happens is, or we teach the model how is tool calling happening. So what we do during this phase is we teach how the model, you need to call the tools. So where are these tools defined, right? So these tools are defined in the server where the model is hosted itself. Like a calculator tool will be available, a search tool will be available, and we teach the model how to look up, call those tools or call those functions and get the answers. Okay. So once tool call training is done, now the model can answer the question like this also, like what is the current time, right? So some tools, like I said, right, tool calling is teaching the model how to call the tools. We'll cover this part more during the RAG phase. It will become much more clear. But for now, understand that the model cannot, like during the learning phase, right? It cannot look up live data. It cannot do math calculation. Okay, it has to be taught those things. How they have to be taught? How this is taught is like a search tool is provided to the model, a calculation tool is provided to the model, a code execution tool is provided to the model. If the search tool is provided to the model, right? Why is this provided? Because model's knowledge is frozen at the training cutoff. Search gives it access to the current information. Okay. So if you ask any question which is trending right now, right? Model has been trained only till January data, but it can answer your current question also. How does it do? It has been given this tool of search that look up the data using this search tool. If you ask it a math question, it does not know how to do the math. It has been given a tool, calculator tool, which can give it do the calculation for it. Similarly, for code execution, when the model generates the code, right? It runs it in a sandbox and uses the output powerful. Then it can give the answer and all. Okay. So this was the model has now in the post training phase. Till now, I have told you about two things, right? First is it's taught how to answer in the form of Q&A. Second was it has been told, it has been trained on how to use tools, right? So that it can answer current questions, it can answer calculation based questions, so on and so forth. Okay. Now, just the last phase of the post training cycle is reinforcement learning. Okay. Reinforcement learning with human feedback. So after SFT and tool use training, the model can follow instructions, use tools, and produce decent answers, right? But there is still one problem. For many questions, right? For many open-ended questions, there can be multiple valid answers, right? And some are clear and some may not be clear, right? Like let's say if I ask it about what is quantum physics, it can answer in a way which is point wise. It can answer in a paragraph. One answer can be right, one answer can be bad, right? We see during initial phases of GPT, we used to see that kind of thing, that it used to give two answers, right? So how does it learn to give the answers in the right form? That is called reinforcement learning with human feedback. How that is taught to the model is like first we ask the model that we give the input to the model and say that, hey, generate multiple responses for this question, right? So given the model a prompt and have it generate two or more different responses. Like my question would be like, wish somebody a happy birthday, right? And I will tell it that generate multiple answers for this question. So model will give me two responses: happy birthday to you, sad birthday to you. Now model now does not knows whether what is good or what is bad. What we will do is here is where humans will come, and what they will do is they will answer they will say that, okay, this was the right answer and this was not very correct answer. So now the model, and we use a reward model that plus 10 for the right answer, minus 10 for the wrong answer, right? So human will come and predict that, hey, this was the right answer. Now the model will see, hey, human said that this one will be the right answer. It will take the human input, it will go and update its parameter based on that, right? That this is how I should update my parameters. So because this response is making much more sense. Okay, this will become more clear. This part I feel that I need to elaborate a little bit more on this part. So I will take this reinforcement learning in the next class as well. I'll repeat this again, that how is the reinforcement learning helping the model. But for now, you can think of it as like the model seeks human feedback during the training phase itself to learn human behavior. Okay. So that is what RLHF is done. So now after pre-training and post-training, the model is ready to interact with the world. And we get the final product, which is like Chat GPT, Claude, Gemini, we get all this. So from an SDLC perspective, this was the life cycle that the model followed. We had raw internet data, right? What did we do? First, we did some collection and filtering, wherein like we removed the duplicates, spam, toxicity, PII information, right? Then data sets were created, right? we took those data sets and did some curation, that I want to build a coding related model, I want to create a reasoning related model. Based on that, I will mix the data. I want 40% of the web data, 25% of the code data, 15% of books data, 10% of academic data. I will do that curation and all. Then the tokenization process, which we had learned previously, which is like I will take this data and convert it into tokens, right? Then we looked into sequence packing and document masking, which means like now I want to train the model, right? So the model takes the input in the form of tokens, right? And a fixed size, 4096, 208, like that. So, and docs can be of varied size. So we club those docs together and we make sure that the context is not mixed by doing document masking. That was document masking. Then we saw batch training. What is batch training? Is like we don't want to send one document at a time and then get back the response and then update the parameters. Instead, I will send a batch of documents, get their responses back, and then update the loss accordingly. Okay, this will make the process faster. Till this part, pre-training is concluded, and we have a base model. That is what we looked at. Now, what we will do is we will take this particular base model and run evals. Okay. Now you can see after doing all this process, right? Let's say this is one training cycle. Okay. After this one training cycle, I will run my eval, that what is the performance of the model. Okay. I will get, let's say, 20%. I will again do this loop, maybe not the content filtering part and curation mixing, because data set I have already, I mean, data set only collection and filtering will not happen again, but curation and mixing can still happen again, because I will see whether I wanted a coding model or something else. I will change the data sets accordingly and all those things. And all this process can happen again based on my eval scores. And then as and when, like when the eval score start improving from 30% to 50% to 60%, then I know, okay, my base model is ready. Now what I will do is I will just teach it via SFT to answer in the form of Q&A. I will teach it tool calling, that, hey, you can also get access to tools like search calculator to answer those kind of questions. And then I will do reinforcement learning with human feedback. Like I will involve humans also, so that I can fine tune the model, that this is how humans perceive this as the right answer or wrong answer. And then this is how the whole model will be ready from an SDLC perspective. And now it will be given to the customers to so that it can be used. So this was the end-to-end process of